Good evening. So for the Gummy Bear Interactive Advanced Concept worksheet, we had the opportunity to perform an experiment with gummy bears. So I chose to use 3 different gummy bears. My green gummy bear was going to be my placebo, so the one that was not placed in water or the water was salt. My red gummy bear was placed in 100 milliliters of water with 25 milliliters of salt. And my blue gummy bear was placed in 100 milliliters of tap water. So before placing the bears in water, I weighed all of them out. Each bear weighed 3 grams before. They were 1.9 centimeters in length, 1.2 centimeters in width, and had a height of 1 centimeter. So I went ahead and took my 2 glasses of water, put the 100 milliliters of water plus the 25 milliliters of salt, added my red gummy bear, and then I took my 100 milliliters of tap water and added my blue gummy bear. I let the bear sit for 10 hours. However, throughout the 10 hours, I would occasionally go back and look at the gummy bears just to see the changes that were happening. I noticed that the red gummy bear in about hour 3 still looked about the same size. The water was a bit cloudy from the salt, whereas the blue gummy bear had already started increasing in size and also had bubbles actually forming around the gummy bear. So after the 10 hours were up, I went ahead and reweighed all of my gummy bears, remeasured them all. My green gummy bear, my placebo gummy bear, was still 3 grams, still had a length of 1.9 centimeters, had a width of 1.2 centimeters, and a height of 1 centimeter. My red gummy bear had a weight of 2 grams, a length of 1.9 centimeters, a width of 1.2 centimeters, and a height of 1 centimeter. So really not too many changes had occurred with the bear that was placed in the salt water. However, my blue gummy bear, and I'll hold up the green in comparison here. My green gummy bear had a weight of 5 grams, so that's an increase of 2 grams, a length of 2.5 centimeters, so that was also increased, a width of 1.5 centimeters, and a height of 1.5 centimeters. So overall, the blue gummy bear had increased. So while most sugary candy dissolves in water, these gummy bears are made with gelatin, preventing the bears from dissolving. This experiment basically looked at osmosis. So osmosis is a process when water moves from a greater concentration of water to a lower concentration of water. For example, the gummy bear in this experiment. The gummy bears in this lab are non-living and therefore they can be considered as semi-permeable. Gelatin is a long chain-like molecule that twists to create a solid form. When the gummy bear is placed into a glass of tap water, it becomes the solute. The solute is the dissolved material in the solution. The tap water is the solvent. Since the gummy bear does not contain water, when the bear is added to the glass of tap water, the tap water then moves into the gummy bear by the process of osmosis. Salt is a much smaller molecule than gelatin. There is more salt molecules in the water mixture than there are in the gummy. The water molecules will move towards the salt molecule to try to even out the number of water and salt molecules in the solution. That is why the gummy bear in the salt water does not grow, if much at all. So, when the concentration of a solute in the semi-permeable membrane and in the solution is equal, it is said to be isotonic. This means that the membrane will not gain or lose any water. If the concentration in the solute is semi-permeable membrane is greater than the concentration of the solute in the solution, then it is said to be hypotonic. In a hypotonic solution, the membrane will swell and may possibly burst, such as in the gummy bear placed in the tap water or my blue gummy bear. Lastly, if the concentration of the solute in the semi-permeable membrane is less than the concentration of the solute in the solution, then the solution is hypertonic. In hypertonic solutions, the cell will shrink, such as the gummy bear placed in the salt water. So the natural tendency for water to want to leave the gummy bear to create an equilibrium is why the gummy bear either stayed the same or shrank in the salt water. So just to kind of rephrase everything that I've kind of said in the beginning is, so when placed in the tap water, water entered the gummy bear due to its hypotonicity. When placed in the salt water, water left the gummy bear, causing it to shrink because of its hypertonicity. So after doing this experiment and looking at the different types of solutions between the hypertonic solution of the gummy bear placed in the salt water and the hypotonic solution of the gummy bear placed in the water, some changes and some potential alterations to this experiment that I thought of are just the differing amounts of salt and its effect on the gummy bear. So if less salt is added, does the gummy bear still grow just a bit? Whereas if an increasing amount of salt is added, so say we had a cup of water that had only 10 mils of salt versus a cup of water that had 25 mils of salt, will the gummy bear in the salt water with the less amount of salt actually grow a little bit, whereas the gummy bear in the higher concentration of salt will just continue to stay the same. Overall, this experiment was very helpful in understanding different solutions, especially being in the nursing field, and when we are resuscitating patients with fluid, just knowing the difference between the hyper, hypo, and isotonic solutions. So thank you.